Well lads, this video is going to go through the 2011 B3 question in higher level. It tells us the 3D graphic on the right shows some makeup items. The balloon diagram shows an enlarged view of the top of the lipstick, which is in the form of a right cylinder that has been shaped as shown. So you can see that picture there. Figure B3 below shows the plan and elevation of the top portion of the lipstick. So that's our two views given here. And then for part A, draw the given elevation and plan and project an end view in the direction of arrow A. So basically draw this part here and then project an end view out in that direction there. Part B, draw the true shape of the elliptical cut surface S. So this surface here, what the true shape that looks like. And then part C, draw the elevation of the focal sphere as indicated in 3D graphic on the right below. So the focal sphere is that sphere there that fits inside the cylinder with the cut surface there. And on your drawing, establish the position of the focal point and directrix for the elliptical cut surface S. So to start off the question, and one more thing to point out, it tells us there it's a scale of 5:1. So basically every measurement given here, the 13mm and the diameter 14, I've multiplied those by 5 because the scale 5:1 to get 65 for my height here and diameter 70 there. So starting off, I'm just going to draw an XY line there like that, and I'm going to draw in my plan first. So I'll just take a center line just down there like that. I'm told is going to be a diameter of 70. So I've taken 35 as a halfway point for my radius. I can then use my compass to draw the circle. So for now, that's all the plan I can actually do. So I can take my widths up then. And my first height is 65mm up to there. I'm told it's going to be inclined then at 55 degrees. So just using the protractor, mark off 55 degrees there. And then from the question I can see there that when I take my center straight up to hit the sloping line here, I can take that across and that gives me this height here as a result as well. Then I'm told the angle here is going to be 70 degrees from that point. So I have to find that point first. So what I'll do is I'll just go anywhere along this line. For example, that point there, I'll line my set square along it there. I'll go off at 70 degrees just there. I'll connect it back here then. Sorry, it should be 70 degrees the other way. Apologies. I should be taking 70 from this end here. So take 70 degrees out this side. Join that back there. And now I'm going to use that and go parallel to it from that point there as a result. So just just use the sliding set squares. So I'm still going at 70 degrees. And that gives me that line there. Now I know where it stops. So just to show you there again, I was going the wrong way initially. That angle there, 70 degrees. That's why I took a random point here, went off at 70 degrees there, so that's 70. And then I use my sliding set squares to move it up to this point here to get that line there as a result. Initially I went the other way, I went 70 the wrong direction. So now I can take this point down into my plan. Now I get that line there as a result. Just mark there, that's my surface S. For the end view, I'm told it's projecting out this direction, the direction of arrow A. So I'm going to take my widths across and then take them up at 45 degrees. And then I'm going to be taking my heights across. Now, for the end view, it's going to appear as a curve, or the cut is. So what I need to do now is divide up my plan into 30/60s, taking my points up to my slope surface there and across, and then take the same across here, up there. So I'll divide this up and I'm going to label each of my points. So I'm going to take these points up to match them. So 3 is going to be up here. 4 and 2 are there. 1 and 5 I happen to hit where I took the random point for the 70 degrees. 0 and 6 are going to be there. 7 and 11 are going to be the top. 8 and 10 are going to be there, and 9 is going to be there. So I'm going to work my way around. So 0 first. So 0 up across. There's point 0. 1 and 11 are on the same line there. So 11 is here, and 1 is there. Then I have 2 and 10. So 2 across to here, and 10 goes across to there. Then I have 3 and 9. So 3 and 9 are already taken up there. There's 3, and 9 is going to be there. Then I have 4 and 8. So 8 goes across to there, and 4 goes across to there. And then I have 5, 6 and 7 left. 5 and 7, take them across, over and up. So 5 is on the same line as 1 in that view. There's 5, and 7 is on the top here, there. And then finally 6, I take up 6 and it goes up to that point there. So for me, the curve that I can see here, I'm going to be going heavy along here because I can see that part. When I look in this way, I can see this portion of the curve, but this portion of the back is going to be hidden detail where it's left over from that section there. So I'm going to lightly connect all my points together first. Just like that there. And then, excuse me, for the back, I'm not going to be able to see it. It's going to be hidden detail from the back. So I'll do it lightly first. And then when I go over, I'm going to do a dashed line then. And this bit curves in here as well, and curves in there too. And it's heavy down on the sides there. And up like that there. So that is our end view. The next part then of the question, it tells us draw the true shape of the elliptical cut surface. So for the next part, I just needed to stick on a bit of paper here. Just when I was recording the first bit of the video, I wanted to make sure you could see the whole elevation, plan and end view. So I've added a bit more paper to the top so you can see this next part here. So for part B, it tells us draw the true shape of the elliptical cut surface. So basically what we need to do is look in perpendicular to our cut surface here. If we look in perpendicular to an edge view, we're always going to see a true shape. So with sliding set squares, I'm going to take each of the points I already have given to me already. So for example, I divide up my 30/60, and on this side here I'm going to have points 7 and 11, 0 and 6, 1 and 5, 4 and 2, and point 3. I'll just extend these a bit further. So as always, for an auxiliary view, we always go 2 views back to get our measurements required. So from this view here, 1 view back would be my elevation, 2 views back is going to be measuring into my plan. So what I'm going to do is, because it's going to be equal distances both sides, for example 1 is an equal distance from here as it is from 5 to there, same with 2 and 4. 2 is the same distance to the centre there as it is from 4 to the centre there. I'm going to take a centre line there and I'm going to use that for all of my measurements. So distance from the XY line down to my centre line is that distance there. I'm just going to take that from any point here. It doesn't make a difference. They're all going to be parallel there, all the way down. And that's going to be my centre line. So that line I've drawn there is the same as this line here. So the distance from the centre here to 0 is the same as out to 6 there. Follow it up, follow it out, mark it off there and there. So there's 0 and there's 6. Same again now with 1 and 5. Exact same distance there each side. There's, if I follow it up, 1 and 5. There and there. There's 5 and there's 1. 4 and 2, same idea again. Follow it up. There's 4. There's 2. And then 3 on its own is already on the line. There's point 3. And then back to this side here, I have 11 and 7, the exact same again. Take 11 and 7 up, take them out each side. There's 7 and there's 11. So same idea again. It's going to be a freehand curve all the way out. Just making sure my 0 and 6 is right. It should be there and there. And then I can go over that. Heavy then afterwards. So that there then is my true shape of S. The last part then, it asks you draw the elevation of the focal sphere as indicated in the 3D graphic on the right. So basically a sphere that fits inside this area here. So it's going to touch off this side, and that slope there. So straight away I know the radius is going to be between there and there. I already have my centre line going up. So what I'm going to do then is I'm going to bisect this angle here to find the centre of it as well, find another line in the centre. So take any distance, swing an arc each side there, and then from there swing an arc there and there, where they cross. I can join them, and that gives me my centre point there. After that then, to get the exact radius and the points of contact, I have that there, which is going to be the point of contact is going to hit off there. I have this here to give me the point of contact off that there. And then it's going to be a tangent edge here as well. I can go perpendicular from my centre to see that the point of contact is going to occur there. So I just get my compass and stretch out to any three of those distances. You'll see there it's the same there, there, and over here as well. So now I can draw in my focal sphere. So there's the elevation of my focal sphere. So I point of contact occurs here, here, and there. Next thing then, it asks you to establish the position of the focal point and the directrix for the elliptical cut surface S. So the focal point occurs where the focal sphere hits the cut surface. There's the cut surface, there's the focal sphere. The point of contact occurred here. So what I need to do is take that out and mark it here. There's my focus. To find the directrix, I take a line across here, because I'm going to be looking at it as an edge view of it. A line across there, so where the focal sphere hits the extreme generators of the cylinder, here and here. I extend that out, and then I extend out the cut surface as well. Cut surface extends out, and they cross over each other at this point here. I take that back then. And the directrix goes on to infinity, but for the sake of this, I'll just say that it stops there and there. I'll put down D, D there for directrix. And that there completes the 2011 conics question. So hopefully that video helps anybody who may have been stuck on this question here.